So we'll be talking today about scaling decentralized exchanges with zkSNARKs, and that's what we've done at Loopring with our third version of the protocol. So just a little bit of background. Loopring is an open protocol for non-custodial, high-performance, order book-based exchanges on Ethereum. I know it's a mouthful. We used to just be more generic and say we're a DEX protocol, but A, we've come a long way and have narrowed our focus, and B, this audience is presumably much more aware of the nuances of the different sorts of decentralized exchanges. They're not all the same, as we well know. On-chain types and auction types, order book types. We'll have a brief look at that before we dive into Loopring construction itself. But basically what we're concerned with now is allowing anyone to build centralized exchange competitive exchanges with 100% security guarantees. So we want the next generation of order book based exchanges like the Binances of the world and Bitrexes to offer their users 100% security guarantees in terms of non-custodianship and not being able to steal their funds, lose their funds, etc.
So you want like that? Who's did it?
So
Like this thing. You already speaking?
Yeah. Oh, that's okay. And just a bit about me. So I do business and operations for Loopring. I come from a finance background. I used to be a bond trader or a fixed income trader at an investment bank. So I come from like a market structure kind of background. That's what initially got me interested in Loopring. So this talk, I'll get into the specifics of how we use SNARKs for scalability, but I'm not a developer. I'm actually kind of the only business guy on the team. If there are deep technical questions, I'll defer to Alex of Matter Labs in the back, who's very familiar with this stuff. So, and just a brief outline, we'll just talk about like why do we care and why do we think users should care, and then we'll look at the actual construction of our version 3 with SNARKs. So, I mean, a lot of this is, again, presumably an advanced audience, and I don't need to espouse the benefits of decentralizations, but specifically, we think that thus far, order book-based DEXs have not really taken root. We have the nice curve-based or automatic market-making types like Uniswap, which are have taken shape, and those are getting a traction, but order books have not. But we think that it's going to be a thing because it's the way that traditional assets trade is on order book structures. It's a way that price sensitive market participants find their price discovery and are able to kind of very granularly control their entry and exit prices, etc. On the note that I just said, pooled liquidity is indeed really cool, and it's unique to DeFi, and it's something that's propelling it, but we will also need order book venues for the professional type traders, market makers, algorithmic traders, high frequency traders, and importantly for porting the liquidity onto the pooled models where the price could be discovered from the order book mechanisms and used to port over and to hedge those positions for arbitrageurs. So, but what do the true traders really care about? Like, this is something we've always known, but it's becoming more and more apparent. High throughput, low cost, low latency, and deep liquidity. I won't need to explain any of that to you. What they don't care for that much yet, much to our dismay, is custody. The people that do trade on order books are really fine with depositing their hard-earned crypto assets on Binance or less notable exchanges. if that's what they need to get to liquidity and high performance, that's what they do. But we think when performance catches up, that we'll be able to, take some of that volume from the centralized exchanges. But one way to go about this is to just make the exchanges prefer non-custody. So if an exchange is spinning up, they could say, hey, I would prefer to build on such a protocol, and their users may or may not even know that they are doing it. So that's the ideal case, is if these exchanges just by their own values and their own kind of business opportunities choose to build on these non-custodial Ethereum level security platforms, and the users don't even have to know. But of course, we do find it an attractive proposition to tell users, hey, you don't need to trust us, you can't get hacked, we can't pull an inside job, etc. So it's kind of two little avenues to go about this. Get the exchanges to want to build, or the users to kind of demand it. And just as it relates to, centralized exchanges, they're important for crypto assets because these are bare instruments, right? We have no central depository clearinghouse, and really importantly, no regulatory clarity on what custody even means across jurisdictions, even intra-United States and across different regulatory bodies. Custody is it's actually not a very well-defined legal concept, surprisingly, and it does involve some interpretation. One thing I find interesting is when you give a custodian your assets and they're well-known and maybe insured and heavily regulated, how do they know, and this is actually a question I have, how do they know that you didn't give that same key to somebody else, right? It's just like a completely different paradigm. Of course, they could generate an address for you and things like, and then they know kind of how clean it is or what's going on. But it just, the regulatory frameworks they're not advanced enough yet. So one thing that, or three things for DEXs that I think it's Tony Shang wrote an article that I like about DEXs. He says, what will actually drive people right now? Non-custodial, that's what I've been talking about, although he doesn't necessarily see that as the prime driver right now. The next thing he talks about is the desire for regulatory arbitrage and people's desire for pseudonymity or anonymity, and this regulatory arbitrage, whether that's tax reasons or certain things that's one thing that DEXs could offer. And the final one that he mentions, which is the long tail of assets, having infrastructure that will allow, in the tokenized world that we all believe in the future, all these assets may need a home that is much more accessible than paying $1 million listing fee, etc. And of course, something that's missing is just all the great DeFi stuff that needs DEXs as a primitive, which thus far has been the on-chain models, but order book models could also be, of course, used for the DeFi purposes and the contract fillable liquidity and stuff. So now before I actually dive into the zero knowledge work that we're doing at Loopring, just to kind of drive this point home about how we think custody is important, here I take a couple screenshots, and I'm not sure about you guys, I'm not the most active trader anymore, but what this is a list from nomics.com, the data provider, about the top ETH markets by volume. And most of these are ETH USDT or ETH BTC. That's what most of them are, but I don't recognize a whole lot of them. I can't imagine sending a lot of ETH, and I'm focusing on ETH here specifically, to some of these exchanges. Some I do trust, the business and the traditional reputation risk, they want to be a going concern, but a lot of them, it's this kind of gives us hope that these exchange, the fact that people are depositing here, this is kind of what's in our first line of sight, that Loopring built exchanges will be able to outcompete these ones with their security guarantees. And again, just another look, this is just from another provider, Crypto Compare. This is not looking at ETH specifically, but just the most volume. And of course we know the plague of fake volume and stuff like that. I think they do adjust for it, but again, we see a lot of grades here in the Ds or worse. So, you know, depositing your assets there, it's just, for some, it's a non-starter. And like, again, really just to, you know, to hammer it home, not to pick on one specific hack or one specific exchange. There's been, you know, over $2 billion of value stolen. But this one's interesting because, again, just focusing on ETH, about 20,000 ETH stolen this year from Cryptopia. Okay, but then 2 weeks later, again, it's just, you know, these things, it happens and it's scary. Like going through the list, a long list of hacks, it's actually quite surreal. And I feel very bad for the people that have been affected. In some cases, the hacked exchange will cover it. This is a recent article, I think from a month or two ago. So 50,000 users affected, $28 million, if I'm not mistaken. They're, I think, being upstanding and gonna reimburse them all. But there's actually other problems that happen when you're even gonna be reimbursed. They're gonna be reimbursed in crypto, I believe, which has had a decline since the hack. So users lost the ability to sell or, you know, make their trades. They're basically long the asset as they wait to get paid. And of course, the opposite could happen, like famously in Mt. Gox, you get paid in the fiat value when your thing rose significantly. So it's like, it could be a lose-lose, whether you get paid in fiat terms or crypto terms. And the final thing we'll look at is just crypto to crypto volumes versus fiat to crypto. We hear a lot about how the off-ramps the on and off ramps to fiat are becoming super important, which they absolutely are. We still see that most of the volume, 85%, happens on crypto to crypto exchanges. Of course, these are more susceptible to like misleading numbers, in my opinion. But and the last thing, the real last thing that came out of this kind of exchange report by Crypto Compare and from Nomics, looking at both those sources, they say when an investor trader enters a trading venue, his or her concerns might be, can I trust the data? Is there potential market manipulation on this exchange? Are my funds secure and insured? And does the exchange have a good API? In my opinion, one of these is just like a completely different bucket. Are my funds secure? I mean, that is risk of ruin, right? That like takes you out of the game versus whereas improper data or like not the cleanest data may make you miss a trade or make a false trade. One kind of is the risk of ruin. So to me, that doesn't necessarily belong in that list, but we see choosing the best exchange doesn't only rely on trading volume, but the quality and trust in the services of the exchange. And with this kind of intro, the trust and quality of the exchange is where we get to kind of what I really want to talk about. And you know, it's a 45-minute talk, so I had to have a little intro, but I don't think we will use the whole time. We'll be able to get to lunch slightly early. But the different exchange categories, we have a bonding curve base, Uniswap, like the kind of the automatic market maker, quote base like Kyber. Both of those are on-chain and you know, are not necessarily meant for the fastest types of trading. It's just simple swaps, or what I like to call like a token store model. Someone says, hey, what can I buy this token for? And here's the price, take it or leave it. Auction based, like the Dutch X that has come out, a Dutch auction mechanism. And then there's order book based, Loopring, 0x. This is where we focus, is on the order book based ones, and we may see hybrids or, you know, currently unthought of models. Who knows what DeFi and Ethereum will allow for, but order book based is what we're talking about. So, Loopring has had 3 generations of itself. We've been around for 2 years. We're based in Shanghai for the most part. I am in Montreal, but we're a team of about 22 engineers who have been building this order book-based exchange technology, and I'll run you through how our thinking has evolved through 3 versions up to the zkSNARKs one for scalability. So first, actually, we didn't deploy this one, like we skipped this one. This is just everything on chain, like the initial Ether Delta, where everything is on chain. So you send your orders there, you're matched there, you're settled there. That is the most, I guess you could say, naive implementation, although maybe some people would go for those properties, but everything on chain. And so we have these characteristics of everything happens on chain: deposits, withdrawals, submitting the orders, canceling orders, absolutely everything. Takes a block confirmation cycle and costs gas. It's as secure as Ethereum, of course, very low throughput, very high latency, and very costly. We may have all used these in 2017. So Loopring did not build this type of model. We started in mid-2017 with just the settlement on-chain, which is also what zkDEX was and is working on, with hosting everything off-chain. Order books are hosted off-chain, orders are matched off-chain, and then you only send a matched transaction to Ethereum to settle for the actual swapping of the tokens. So here, what you need to do on-chain is the ERC authorization, the ether wrapping, cancel orders, settlements. The cancel orders has a little asterisk because you could cancel it through the order book hoster, the relayer, but you can't trust that they fully took your order, like, cancel it. The only way to be certain is to kind of fill it yourself, like void it yourself. Characteristics, again, as secure as Ethereum. Throughput was still very low, high latency, and a bit better on the cost front, but still very high. So that is what Loopring version 1, 1.5, and 2 were built on. And we saw not a lot of take-up, to be honest. We did have some DEXs building on top of us. Most were kind of like what I would call hobbyist projects, because we provided some reference implementations that people could just fork, reskin, different paint job, and we had like a back-end relayer implementation that they could hook up to. So it was semi-trivial for them to spin up a DEX, but it wasn't economically feasible, and so we didn't have very good take-up. Now, the main thing that I want to talk about now is the proof on-chain. So where we do absolutely everything off-chain. So just like before, order books hosted off-chain, matched off-chain, now even settled off-chain, put into like a big batch, proven in a zkSNARK, and just that proof is put on-chain. So what we have happening on-chain is deposit and withdrawal requests to kind of enter the account system of a DEX. You have to make a deposit, an on-chain deposit, and then your account, you're created like an account in an off-chain data structure, a Merkle tree in this case. And then what's put on-chain is the state hash of that off-chain Merkle tree, a proof which proves that everything was executed faithfully, that all deposits, withdrawals, and trades, complied with the protocol rules, right? That's what SNARKs and zero-knowledge proofs are good for, is this verifiable computation that something was either executed faithfully or not. And super importantly and interestingly is the on-chain data availability, which is technically optional in Loopring version 3, but we do focus on the case with on-chain data availability, which is what's called zk rollup. When you do put that, when you have that on-chain data availability. So again, so this is the DEX state. And we have the root, and so people, each Ethereum address has an account, and you could create an account trivially, like you could spin up a new one. Each one maps one-to-one, an account ID to an Ethereum address. Like I'm not an expert in the design of this Merkle tree. It's a bit beyond me, but I know we try to optimize by using subtrees, so we don't, like, to do certain things, we don't have to traverse the whole depth. We could just, kind of stop there to do certain transfers. We don't always have to go to trade history, which is the bottom set of leaves. But this is what a DEX is. So everything's happening off-chain as, fast and cheap as legacy tech, with the computations being proven in the SNARK and that being verified by the Loopring protocol smart contract on-chain, which just reads the proof and says, yep, everything fits the rules. So just to sum this up, what exactly happens on-chain? You have deposits, withdrawals, so to kind of enter and exit that Merkle tree, you do an on-chain transaction, and then you have a block commitment and verification, which basically in batches puts things on chain and verifies them. But of course, not the whole data needs to go on chain. I'll talk about exactly what does need to go on chain. So the characteristics, it's as secure as Ethereum. Again, we have an asterisk because which I'll get to in a second, but in our opinion, it was the most secure scaling solution. It provided the best guarantees as Ethereum-based layer. Throughput is very high. It's 350 transactions per second in the data availability case, on-chain data availability case, which again is the most secure version. Without on-chain data availability, we could go to 6900. Very low latency, again, just updating that Merkle tree basically, so it's milliseconds. It's super cheap. It could cost thousandths of a penny to settle a trade. And we have what we call apparent immediate finality, meaning the DEX could update its state on the click of a button, like we're used to on Coinbase and Binance. So these are the characteristics of what makes a Loopring v3 DEX or a zk rollup DEX. And so here are the numbers. I just spoke about the throughput numbers. After Istanbul, though, we are quite excited because we will be able to benefit from a reduction in the gas cost of call data, EIP 2028, which reduces that cost by a factor of 4. So we'll be able to get up to 1,400 trades per second. This is the number where it will actually be operating at, where some partner DEXs that we'll be building on top, this will be the number with the most secure assumptions. And if they want to drop it, of course, they could go higher. And just to see how many trades does that work out to in a day, it's a lot. We could do 121 million trades per day with the on-chain data availability case. This is post-Istanbul. I'm just putting this number here because sometimes I look at how many trades happen on DEXs in a week, and it's like a few thousand across some of the leading protocols. We have like Uniswap, I think, does like 10,000 a week, and Kyber around that, maybe 8,000 trades. 0x, again, like 5,000 to 7,000. I don't want to misspeak, but it's about that in a week. So how many could we do in a day? I think we're above where we need to be for the natural demand right now. So that's exciting. Now just to run through some of the numbers. And let me put it over here. Okay, so the cost per trade scales with okay, actually I want to back up for 1 second. The on-chain data availability, I'll get that out of there just so it's easier to think about. we have to put, so a DEX is keeping track of their Merkle tree. Let's say 4,000, that's how many we could fit into a virtual block. 4,000 things happen. On-chain deposits, withdrawals, and trade settlements happen. All these little state changes are batched, and the change in the root of the Merkle tree, maybe I should go back to that, it'll be a better visual. The change in the state of the Merkle root, or the Merkle root itself of the new state, is put on chain, and so is the old Merkle root. So all we're doing after like 4,000 little changes here, we take the new Merkle root, we put it on chain, and that represents, let's say, 4,000 trades. What the on-chain data availability part, this is super important because this allows anybody to look at like the interim state changes that brought us from an old state of the world, represented from the old Merkle root, to the new one. How did we get there? The on-chain data availability asks us to put the delta of the leaves of the tree. So we put a bit of information which says how each leaf changed, and it's possible I misspeak like at the corners of these cases because I'm not super technically inclined on that, but we have to put the deltas of the intermittent data with the roots, and that's what allows anybody to look at the Ethereum blockchain and say, hey, I see how I got from one state of the world to another. I could reconstruct it myself very easily. So with on-chain data availability, you could always look back at a DEX and say, hey, yesterday I had, this amount of money. And you could always kind of point and say what the state of affairs was. And how you know that you'll always be able to have that data is because it lives on Ethereum, which is this eminently available data layer. So a common way to phrase this is that we use Ethereum as a data availability layer, and we do all the computation off-chain, just verified by the SNARKs. So that's how that's how this works with the on-chain data availability. Now here the proof. So after you do this, then like a clock starts, and you say, hey, okay, you just submitted. It's called a commitment. You just committed a new state of your DEX. Now you have to prove that all your updates were executed correctly, that all the signatures were correct, that the limit prices were honored, that you followed the protocol rules, that you didn't just randomly take that guy's money, put it there, fill that guy at a worse price, fill that girl at a better price. You have to show that you followed the constraints of the protocol. So then you start actually proving the SNARK, and you have, let's say, an hour to after you've done the commitment, to put the proof on chain and say, hey, everything is indeed what was computed correctly. When you have that proof, that is like the seal of approval. So now you have the commitment of the new state, you have the proof that shows everything was great, and you have the data that could allow you to go backwards and reconstruct the Merkle tree. So now we'll get into some interesting properties. And okay, so now here's just some of the numbers about how economical this is. So again, with data availability, it costs us about 385 gas per trade. That's for that call data to put those deltas of the leaves, and there's also like an overhead cost of about 350,000 gas just for the commitment, which is like that batched part. So yeah, let's just put this into some numbers. I calculated this one is at 6 Gwei and $200 ETH, and these are the costs we get. So very low. The proof generation cost is the off-chain cost to prove that SNARK. So just the cost of running the computations on your AWS servers or otherwise. So you have kind of two buckets of cost here. You have the on-chain gas component for the block commitment and the verification of the SNARK, which also costs money to verify the SNARK. And then you have the proof generation cost, which you could play with as you see fit. You could spin up more servers to prove faster if that's something that your app or DEX requires, or you could go cheaper and prove slower. But you see we're at a point where settlement is super cheap versus the old way and Loopring 2.0, which is 33 cents at these factors. So we kind of just spoke about this, so I won't spend too much time, but the cost of data, we have to send in the call data for, so this is what limits our throughput, is the cost of the call data. Again, EIP 2028 gives us a nice little tailwind there, and that's the cost per ring. And then committing and verifying a proof costs 350,000 gas, which goes down quite a bit again after Istanbul. But so this means that multiple blocks can be committed if needed. This is the bulk stuff, the commitment of all the things, and then the verifying of the proof. And then in the actual SNARK, in the circuit, we have 256 million constraints, which is the limit that allows us for the efficient proof verification. This number comes from the fact that the elliptic curve we use has 2 to the power of 28 constraints. This would be better for Alex, but 2 to the 28 of alt BN 128. So that is like, I would be able to change with a different elliptic curve. But our ring settlement circuit with on-chain data availability uses about 70,000 constraints in a ring. So that's why we get to about 4,000 settlements in a virtual block. The blocks that the DEX operator are creating, you could fit 4,000 into one SNARK. Okay, so now let's just see like what we've actually come up with by using all these tools. When a DEX says that something just executed, what they're really saying is this will be cryptographically guaranteed. In the meantime, you only have an economic guarantee. Because, remember, you commit the block, but then you have 20 minutes to verify it, to submit the proof, and then the smart contract verifies it. In that interim, there's technically nothing's been proven, but you have an economic guarantee because these DEXs must stake LRC, our utility token, to have some skin in the game to say, hey, I'm committing this, I'm going to prove it in 20 minutes, but I don't want to like disrupt your trading activity. I don't want to have to like go backwards 20 minutes and revert the state. So here is, you know, some dollar value of LRC. If I fail to submit the proof, or I'm too slow, or I never have an intention of submitting the proof, I'm going to be slashed. So that's why that little asterisk was there when I said as secure as Ethereum, because at one point you only have this economic guarantee, not a cryptographic guarantee. And again, this just keeps it so that the DEX is incentivized to not revert the state before the proof, the cryptographic finality, is finally submitted. So this is, these are like the two forms of finality. After about, again, the number is indeed 25 minutes. We think we have like an hour window though that will allow people to submit proofs in. That's a factor we could play with. Okay, now this is cool, and this is kind of what gives us the big security guarantee of version 3. Remember, we say that there was no way you could lose your funds. This is because when I, as a user, am trading on a Loopring version 3 DEX, I want my money back. I submit a withdrawal request to the DEX, and they have to they have to process that transaction. They need to say, okay, Matthew wants to withdraw his money. It's time for me to update my Merkle tree by taking Matthew's money in his account out and putting it back in his Ethereum address. If after 15 minutes the DEX did not process my withdrawal, then he can't do anything. He's basically incapacitated. This holds true even if there's one withdrawal request. Let's say there's a DEX with 1 million customers. If one girl sent a withdrawal request that didn't get processed, after 15 minutes, again, this is a configurable parameter, but we are indeed talking about 15 minutes here, then the DEX cannot operate its business anymore. It has to process that withdrawal before it could start matching trades, taking further deposits, doing anything else. It could only process withdrawals after that 15-minute point in time. Then, let's say it's still slacking. It went offline or it just stops doing its job. It doesn't want to be a DEX anymore. After 1 day of this, where he only was able to process withdrawals, but he still hasn't, after 1 day, again configurable, likely will come lower. I find this a bit much. Then withdrawal mode happens, or what we could call shutdown mode. The exchange is shut down. Like his game is over. His game is over. He loses, his ability to do anything. The contract's shut down. It's like he could restart a new one, but like you literally have to tell all your users to, all the hassle of moving, migrating. So it's shut down after 1 day. Then at this point, this is where this is what we're after, that users cannot lose their money. Users can then retrieve their funds themselves by submitting a Merkle inclusion proof, which says, hey, the last time that the DEX state was proven, this is the amount of money I had. And when I submit this proof, I could withdraw my funds myself. I don't need to rely on any third party, not on the DEX, on anything. And that is why the on-chain data availability is so important, because it allows me to sequentially go. I could go from a month ago and see all the different deltas of the leaves and say, oh, yesterday, or let's say yesterday in this case, this was how much money I had. Here is my proof. I have reconstructed the Merkle tree by this eminently available data from the Ethereum blockchain. Here it is, and now I get my money back. It's that simple. That is why without the on-chain data availability, we can't offer that guarantee, because somebody might not be able to recreate the Merkle tree to yesterday to say this is how much money I had. Of course, maybe they could find the data another way. Maybe there's like a group of some trusted parties, maybe some auditing firms, wants to keep the state on a database. It's like some consortium of notaries that wants to keep the state. But again, that is not the same security guarantee as it being on Ethereum itself. So this is the big draw. Always get your money back yourself. And in this case, what's the worst that could happen? What's the worst that could happen? You waited a day. You lost a day, but you did not lose your money. Whereas without the on-chain data availability, by the way, the DEX cannot steal your money. You can't just, make things up. You can't steal your money, but it's locked in that unknown state. So effectively, that's like losing your money. Like, I don't care if you stole it so much, I just care if I could have it back. If it's locked in limbo, it's no good to me. That's why we focus on the on-chain data availability case. And this is akin to just a global shutdown and like the maker, it's like the backstop, the final backstop of the system. I will just run through this very quickly. What can you see on-chain? The data is on-chain for security. You can see what actually happened, the trade data. So like the token, the amount, the account ID, which maps to an Ethereum address, the fee paid. That is all viewable on-chain, and we're building, let's say, an Explorer that allows you to easily see this. What you can't see is the original trade data. Like, if I was filled for like half an ETH for a maker, for MKR, I could see that on-chain, but if I actually wanted to do 4 for 8, like whatever the original trade was, I can't see that. That I have to see off-chain, or like just in like a normal exchange environment where I could see orders from their API that they expose. So I put this up here because a lot of people ask, hey, what can I actually see in such a construction? So what are we really going for here? And this is, I call it this better than sex guarantees. And we have never lose your funds, never rely on anyone to get them back. You submit that Merkle inclusion proof, you have your money back. It's also costlier to fake data and volume. Some people say, hey, Kent, in this way, a DEX operator could still make a bunch of trades up, a wash trade. That's true, but there's that cost of there's that extra Ethereum cost, right? There's that call data cost. So they could do it, but it has a cost, which, as we all know, these economic disincentives or incentives is what makes most of this possible. So it's costly to fake that sort of stuff. Also, they're taking up room in their finite block. It's not like they can just print numbers. Let's say they are actually a very busy DEX, then it really behooves them to include real volume, which they're earning fees for, versus putting their own fake volume. And you can't, arbitrarily rewrite trade history, which is, I guess, an outside risk. What we can't guarantee is right now we don't implement any privacy-preserving technology here. A lot of people always think zero-knowledge proofs are just great for privacy because Zcash and other, really prominent projects, but we just use it for kind of verifiable computation off-chain. No privacy. We actually could implement privacy, but it makes our circuit much less efficient, much more expensive. In this case, 10 times more expensive. For now, we are going for high throughput, low cost, high performance. Privacy, maybe we'll be able to take advantage of a different thing going forward. We can't prevent wash trading, again, but it makes it more costly. And we can't prevent front running by the exchange itself. The exchange, if I submit an order, he could front run me or censor me, kind of the same thing here. But, that is something we're able to live with right now because we're much more concerned with just the non-custody stealing of the funds. Normal, traders, they do trust centralized exchanges and NASDAQ in the legacy world and Binance in the crypto world to not front run them. If they were constantly being front run, you could prove it or at least point at it, then they'll just take their business elsewhere. Or in this case, you could start using a different operator who doesn't front run you. Maybe, there's still business risk and kind of reputation risk. One thing you could also do is instead of sending all these batch of transactions to a single operator, you could have a contract which has a bunch of sub-operators in it that kind of vie for a chance to submit that proof. So maybe we have a bunch of operators combining and they are trying to each win a slot to make a proof. And this is just one thing. One thing we're spinning out now for the first time, which is kind of cool, is a relayer as a service. We call it Litecoin. This now means all that zero knowledge stuff and the order books and the matching. So the matching engine, the hosting, the proving, we wrap that up. We call it, it's a relayer or an operator as a service. So now a DEX could just literally spin up in one, not even deploying a smart contract, but just a calling a function on a Loopring protocol smart contract spins up your exchange and your back end is completely taken care of, trustlessly. And it's cheaper than ever to run this exchange with, you don't need a huge cybersecurity team. It's basically outsourced to Ethereum with all the guarantees. You could pass these savings on with lower fees. I'm trying to rush through this. I have 2 minutes left. Focus your efforts elsewhere. These are different deployment modes, different sorts of upgradability. You could automatically upgrade, you could manually upgrade. I'm sorry to rush through this. It's currently being audited in an internal beta, invitation next month or so, and with on-chain data availability fully to the public by the end of this year with a few DEXs building on top. What's next? Things we could look at, cross-chain, implementing derivatives and margin trading, and privacy, as we said. And that is, that's pretty much it. I'll run through these fast, but we went through a lot of these, and we've learned a lot working on this in the past year, and we finally, the big takeaway is we finally feel that DEXs, order book DEXs, are commercially feasible to compete with centralized exchanges, and that's what we've been after. So thank you guys so much for bearing with me. I know that was a lot to unpack. Thank you. Any questions?
Sorry, can you guys use the mic?
Oh.
Oh, and if you can you repeat the question to the camera?
Sure.
Do you have any benchmarks in terms of how many transactions per batch you're assuming and how much gas a batch costs to verify depending on its size?
So transactions per batch are, I think it's like 3,900 or so. I get that from the number of the 68,000 constraints per ring settlement into the 256 million. The cost to verify it, I'm actually not sure how you split up the commitment versus verification, but as you saw, it's like 350,000 gas currently, and after Istanbul, 225,000 gas. I'm not sure how that, I think that's fixed overhead. Maybe you would know better than me if this is an area you look at, but does that make sense? Okay. One thing, a DEX could not wait to 3,800 transactions. Maybe after like 10 minutes, maybe they're not that active, they just commit it as is, but the full thing would be around 4,000.
Are there any substantial differences to the Stark DEX design if you're familiar with it, other than that you're using SNARKs?
Yeah, it's a good question. Yeah, besides the SNARKs and Starks trade-off, there's some small little things. I know one big thing is I don't think they're going for on-chain data availability. I think they plan on using like a consortium of sorts. So that's one, so that gives them more room for performance, but I think a bit of a sacrifice on a lesser data availability layer than Ethereum. Is that right, that they're not?
Yeah, I think that's what I heard.
Yeah.
And it sounds like your prover is pretty slow, so they're claiming, because you mentioned this 20 minutes to an hour kind of thing, they're claiming that they can prove this in like a couple of minutes. So that seems like one of the big, in terms of the benchmark for batches, it sounds like you're roughly in the same spot. This prover thing sounds like, is that right? That you're still working on the proving time?
So right now, so everything is open sourced except for the relayer, like the light cone relayers you saw, but the circuits are open source. The prover, we don't actually have, as far as I know, any fancy prover. We're using just like from libsnark. We may be able to optimize it. I know we've done some GPU optimizations. We've started with that. But one thing, that 20 minutes, like we could make that a lot lower with a higher cost just by throwing more machines at it. And that may, like, I'm not sure that's something people care about. If, oh, what is my time frame between economic finality versus when the proof is actually submitted? But yeah, I think, yeah.
Okay, cool, thanks.
Thank you. Okay, thank you guys very much. I appreciate it.